Okay, good everyone. So you're welcome to this week's class, and it's on visualization. So here we learn to visualize our results. How do we plot graphs in Python? So I'm going to use spider. So to plot graphs in Python, we need to import matplotlib. Okay, one of the best ways to import matplotlib is to say import matplotlib.pyplots as plt. Okay, import matplotlib.pyplot as plt. So that anytime we need to use a plot function, we just call plt. Then we also need to import Python. So let's some functions in Python. Let's say from numpy import. We need sine, cos, tan. What else do we need? Square root, pi, range, linspace. So I think these are some of the things we'll need. So if we need others, we'll import them. So let's say we have a number from 0 to 2 pi. Okay, so let's say x is from, or theta an angle is from 0 to 2 pi. So let's use a range. So I've explained a range before. So you have the starting point, which is 0. Let's say 0, and the end point, which is, let's choose 2 times pi. Then the spacing, let's choose 0.01 as a spacing. Then we say y equals sine theta. Then what to plot? So let's say plot x, y. Sorry, we'll say plt dot plot. Then plt dot show. What's the error here? Undefined name x, okay, sorry, theta. So that's the advantage of using spider. So it will point out the errors in your code. So if you run this, we have this beautiful graph. Okay, this beautiful graph. So this is what we have. So this is a plot of sine theta against theta, where theta is from 0 up to 2 pi. Now if you look at this plot, it is not labeled. So we need to label the horizontal axis as well as the vertical axis. So we can say plt.x label. So the x label is actually theta. So let's say theta. Then the y label, plt.y label, sine theta. So let's say sine theta. I think I need to put r. Okay, let's see if r is not necessary. Okay, so r is necessary. Okay, so I have okay, let me start from something simple before I use let me comment this out. Let me just cut. So this should be clear. Okay, now if you want to label, so the code is that you say plt.x, that is for the horizontal axis label. Then what do you want to plot on the horizontal axis? Let's say x. Then the vertical axis y label, let's say y. Okay, but the y must be integer, must be a string. The x, so in everything that you have in the label must be string. So that's why we have this inverted. So you can say y, x. So x for the horizontal and y for the vertical. Okay, so but in our case it is theta. So how do we write theta? So this is where you need to learn some LaTeX command. So you say \theta, but before you do the backslash, it must be in dollar. Okay, then \theta, then you put this r. So but in some cases you may not need to put the r. Okay, so the r, then dollar again, sine, so sine, then theta, sine theta. So if you do this, so you have your sine theta and theta. So we have labeled the axis. Okay, So the horizontal axis is labeled as theta, and the vertical axis is labeled as sine theta. We can also do scatter plots. So what we have done here is regular plot. We can say PLT dot scatter, so that we have a scatter plot. Okay, we have a scatter, but it is too thick. Let's change it to 0.1. Okay, so you can see the scatter plots. Okay, scatter plots. Now, but well, that's about scatter plot. But in this course, we'll focus more about because we can also generate a plot that's similar to scatter, even using these plots. Okay, by editing editing the code. Okay, so we have learned how to plot graphs and how to plot scatter plots. Then also how to label. Okay, next is how do you save your figure. So we have gotten this figure, this beautiful plot. How do you save it? So you say plt.savefig, save fig. Then what is the name of the figure? Let's say sine figure, sine figure. Dot what? You can use dot EPS, that is encapsulated postscript, which is the best if you want to publish a paper. So the best is to use EPS. The second best is to use PDF. Okay, then others we can use PNG or JPEG. Okay, but I do not really recommend using PNG because the graph is not usually not beautiful. So let's save and see. So let's go to our, so now if you want to know where the figure is saved, you have to go to the directory you are working. For me, I'm working at home, physics, document, course, top up class, up to plot week 4b, so I'm here. So which is this place? So this is my plot. This is my plot. So sine theta against theta. Okay, but as I told you, this is not the graph is not sharp enough. So let me save this as EPS. Okay, or you can also save it as PDF. So let's look at the EPS. This is the EPS. You can see it's better. The EPS is better. Okay, you can also save it as PDF. So PDF, so PDF, and you can check PDF. Okay, so this is PDF. So if you are publishing a scientific paper, I strongly recommend EPS. So if you are not using EPS, then use PDF. It's not good to use PNG or JPEG for a scientific publication. The figure looks mature-ish, sort of. All right, so that's how you save your figure. So we have learned how to plot graph. So after you have generated your data, this is the horizontal axis, and this is the vertical, and this is to plot. This is to label x-axis, and this is to label the vertical axis, and this is to save fig. And this plot dot show is to show the figure. Okay, is to show the figure. But if you have already saved the figure, there is no need showing it again. You can just go to where you saved your figure and look at it. Okay, so but if you are not saving the figure and you want to view it on this panel, okay, then sometimes you need to use plt dot show. Okay, I believe that's clear enough. Okay, then I have this simple example. So the example is that let's plot the function y equals sine 2x for x in the range minus 2 pi to 2 pi. Okay, so we import matplotlib.pyplot as plt. The minimum, x minimum is minus 2 times pi. The x maximum is 2 times pi. Then x is linspace. So to generate data, you can use a range, you can use linspace. The linspace uses minimum, maximum, then the number of points, while the a range uses minimum, maximum, and the spacing. Then y equals sine 2x. So if you plot, then this is what you have. This is what you have. Okay, this is what you have. So you should try that. Now, what if we want to plot two graphs, okay, on the same figure window? So for example, we have let's say y1 equals sine theta and y2 equals cos theta. I think we have imported cos as well, cos theta. Okay. So cos theta. So we now say PLT dot plus theta y1, then PLT dot plot theta comma y2. Okay. So we now so I think we can view the graph now. So don't let us save this first. Let's just view it. So we have the first one is plotted. So there are two graphs plotted. But of course, if you know mathematics, you know that the blue one is sine and the red one is cos. But okay, let's start. Let me do it gradually. So we have two plots. So one is the y1, which is sine theta, and the second one is what? Y2, which is what? Cos theta. Now, so how do you label your plots? So you label using legend and as well as the label tab here. So label equals sine theta. So maybe sine theta. Let me just say sine x for yeah, I think I use sine x here as well. Okay, but let's use sine theta, but we have to use dollar as well. Then for this we use label equals dollar again cos theta. So I think we should put r as well. Okay, cos theta. So let me reduce this. Okay, so the first one is to plot theta against sine theta. So we label it as sine theta, and the second we label it as what? Cos theta. Then we say PLT dot legend. Okay, so that there will be legend. So the legend will tell us which one is sine theta and which one is cos theta. So you can see sine theta is in blue, while cos theta is in what? Is in red. In fact, we can okay, let me do it gradually. So let's save this and view it. Let's say sine cos 1. So PDF. So save, so that you view it in a, this is it. So this is what we have plotted. So the blue one is sine theta, and the red one, or is it red or orange, is cos theta. Okay, and I mean the labels are also there, the x label and the y label. Now, what if you want to specify another color? We want to use another color instead of the default color. Okay, so we can do that. We can change color. So we can say let's say red for this one. Then for this, let's say blue, so that we use red and blue. Okay, red and blue. So we have used red for, so R is for red and B is for blue. We can also use other color like magenta. Okay, magenta. We can use cyan. What else? We can use black. Black is K. So red, blue, yellow is Y. Green, I use green. Red, blue, green, yellow, magenta M, cyan C, black K, and so on. Okay, so I think if I'm plotting just two, so I prefer to use red and blue. I think they are very, very good. Yeah, I prefer to use red and blue. So it's a choice actually. Okay, so what have you learned? We have learned how to plot two graphs on the same figure window. Okay, and we have also learned how to use legend. So you have to label. So I said label equals, so the reason why we have all this is because of the equation I want to write. So, and I think it's important for a physicist to learn a little of LaTeX. So it will make your plot to look scientific. Okay, so if you want to use LaTeX, so sine is sine. You just need to put this backslash. If you put this backslash, so it will write it as LaTeX sign. Then this R, sometimes you may need to put it. Sometimes in some, maybe I don't know, maybe in your operating system you may not need to put the R, but in case you need to include it, so include it. Then theta, you just put backslash, then you write theta, but everything must be in dollar, of course in quotes, because they are string. So all this is string. The same thing, everything here is string, so they must be in the quotes. Okay, so that is about that. So legend, then you say plt dot legend, that is to include this sine theta and what, because this is the legend, okay, to tell you what each line, okay, represents. Okay, what else? So there is this example that is here, so classwork, so you should try to do it. That, like, you should plot the functions f1 of x equals ln 1 over cos square x, then f2 1 over sine square x, where x is in the range -20 to 20, and you should use 1000 points. So to generate this data for x, it means you should use linspace. So the minimum is -20, maximum is 20, and the number of points is what, 1000. Okay, so that is the plot. Then this is another assignment. That the normalized Gaussian function centered at x equals 0 is this. So plot and compare the shapes of these functions for standard deviations. Sigma equals 1, that's this sigma equals 1, sigma equals 1.5, sigma equals 2. So you have to write a function for this. The function will return sigma, will return this, and it will take in as input sigma and x. Then you cannot vary sigma. When the sigma is 1, you plot the graph for x. When sigma is 1.5, you plot the graph. Though I think I've solved it, but I think I have not solved it. So I think this is a good exercise. Yeah, this is a good exercise. So please submit this assignment. Okay, it's a good exercise. Okay, so yeah, please submit this assignment. Then labels and legends, I think I've explained that. So how to add label. Aha, so you can increase, if you look at this, okay, the sine theta and cos theta, they may be small. In some cases they may be small, so you may need to increase the font size. The same thing with the x label and y label, you may need to increase the font size. So how do you do that? So just say font size. So for the x label, then you can say font size equals maybe 20, so it has increased. The same thing for the y label, font size equals maybe 24. Can you see? So it is big now. Okay, it is big. The same thing for the legend. You can say font size for the legend equals maybe 16. So you can see the sine theta and cos theta, they are bigger. In fact, you can also increase the line width. Let's say equals to line width equals to. So line width means the thickness of this line. So if you save, it is thicker now. So let's look at this sine cos graph again. This is it. You can see that line is thicker, and everything is now bolder. Okay, everything is very bold. You can even increase this thickness to 3 or 4, but if it's too much, then it will not be too beautiful. It will not be beautiful. So I think 2 is okay for this particular graph. So line width equals 2. So and so on. So there are many things that you can actually do. You can use different colors. I've explained different colors. Blue, B for blue, G for green, R for red, C for cyan, magenta, yellow, black, white, and so on. Then different line styles. Okay, I think that's the next thing I will explain, the line styles before these multiple figures. So for these graphs, we have used a single line style, which is the solid line. Okay, we can use dashed lines. Can you see? The cos is now dashed line, dashed. We can also use dotted line. Dotted line, use colon. Okay, like this, it will be dotted. Okay, dotted line. Okay, you can also use dash dots. So you use dash, then dots, dash dots. So you can use different lines. Okay, so let's say we have, y3 equals sine 2 theta. So 2 times theta. Then y4 cos 2 times theta. Then we say plot y2 y3, and it is sine 2 theta. Okay, 2 theta. Then again plot y4, which will be cos 2 theta. Sorry, y4 cos 2 theta. So let's label, the first one be solid red, then the next one be dotted blue, and the next one will be dashed magenta, and the fourth one will be green or yellow, anyone, green. Okay, yeah, so that is it. But now the legend is now too big. So we can reduce the legend to 12 or 10. Okay, yeah, so you have sine theta, sine 2 theta, cos 2 theta. Okay, so there are various, so if you have more than that, okay, so you can use I think that, yeah, so the dash, the solid line, the dashed, the dots, the dash dot, and so on, and you can use different colors to separate the different plots. So next is multiple figures. Okay, what do we mean? We mean something like this. You know what we did here was to plot. Okay, so this sine theta, this label here should not be there again. Let's remove this. Okay, because it's not just sine theta again, so there are many other functions. Okay, so this, we have plotted them on the same plots, but what if we need to separate them like this? Okay, we need sine theta to stand on its own, cos theta to also stand on its own. So what do we do? That is when we use subplots. What I call it? Subplots. So this is the trick. Okay, so everything that I've done here, let me copy and comment this and comment them out. I think I can delete this. So Control C, then comment them, Control 1. Then let me paste. Okay, so I want to use subplot now instead of just saying plt.plot. Now it is recommended to give your figure the figure size. Okay, figure size. So let's say figure size. Then so figure size 12 by 5. That is, the length will be 12 and the width will be 6. Let me use 12 by 6. So it's a rectangle. Then subplot. Alright, so what you do is you use subplot. So plt dot subplot. Now the subplot, if we want to plot, let's start from 2 plots. So if we want to plot only y1 and y3, okay, then I want to plot them horizontally. Let me explain what I mean. Where is this? Increase. So we want to plot one figure. Sorry. So one figure should be here, and the second figure should be here. So in this case, we have 2 plots there, but 1 row. So 1 row will be one row is 1, comma, how many plots? 2 plots, 1, 2. But if what you want is one figure to be at the top and the second figure to be at the bottom, then it means this is 2 rows. So it will be 2 rows, then 1 column. Okay, this 1 column, 2, 1. So if you want it like this, then your subplot will be 1, 2. If you want it like this, then your subplot will be what? 2, 1. So let's say we want it horizontally, so that we have just 1 row and 2 columns. Okay, then the first one, now the first one is this. Sorry, Control V. This is the first one. Then this is the second one. The second one will be 1, 2, 2. That's all. So 1 row, 2 columns. So in the 2 columns, this is the first one, and this is what? Second one. So if you plot this is what we have. So let's say mult 1. Let's call this mult 1. Okay, so this is what we have. Okay, so let's go to mult 1. This is what you have. So one figure is on the left hand side and the other figure is on the what? Right hand side. Okay, but I think the figure is not complete. This is not labeled, so let's label. Control C. So let's label this plot. Okay, what else? The Y label. So let's copy the Y label as well. Y label, then Y label for this also. So I think this is sine 2 theta. So R equals sine 2 theta. Then legend. Okay. So for the first one, subplot 1, 2, 1. So we plot, we label legend. 1, 2, 2, we plot, we label the legend. Then we can now save the figure. So I think we can check it again. Okay, so sine theta, sine 2 theta. Okay, now that is for the first two. Now what if we want to plot the 4? We want to plot the 4. That is, we have one here, another one here, another one here, another one here. So it means, how many rows do we have here? 2 rows. How many columns? 2 columns. So it means we have to change our plot from 1, 2 to 2, 2. That is 2 rows and 2 columns. The same thing here, 2 rows and 2 columns. Okay, 2 rows and 2 columns. So 2 rows. So it means this is the first one, this is the second one, then this will be the third one, and this will be the fourth one. Okay, so the third one is this. So let's cut it. So that is 2, 2, 3. Then this will be 2, 2, 4. So there are 4 now. So 2 rows, 2 columns. 1, 2, 3, 4. Okay, 1, 2, 3, 4. So let me delete this and put the actual plot. Then for this as well, cut. Okay. I think I should reduce the size so that you'll see everything. So let me explain again. So for this, we want to plot 4 plots. That is, we want to plot them like this. So you have to determine what you want first before you give the command to Python. In our case, we want to plot 4 graphs. So one of them will be here, the second one, the third one. So here we have 2 rows and what? And 2 columns. So our subplot will be 2, 2. Then for this one to be comma 1, for this one it will be comma 2. So we have 2, 2, 1, 2, 2, 2. Then for this one, for this one to be 2, 2, 1. For this one to be 2, 2, 2. For this it will be 2, 2, 3. And for this to be 2, 2, what? 4. You know, for this one is 1 row. So 1 but 2 columns, 1. And this one is 1, 2, what? 2. While for this one, this is 2 rows. So 2, 1, 1 and 2, 1, what? 2. But this case, there are 4 plots. So there should be 1, 2, 3, 4. How many rows? 2 rows. How many columns? 2 columns. So that's why you have 2, 2. Okay, then 1, 2, 3, 4. Okay, so 2, 2, 1. Then you put the plots. You label it and legend. 2, 2, you put the plots, you label and legend, and so on and so forth. So yeah, so let's take a look at that. So yeah, a beautiful graph. Okay, beautiful. But I think we should increase the size instead of 12 by, so let's say 12 by 12 now. Okay, so 12 by 12 because it's now square. Okay, if it's rectangle, then we can use 12 by 6, but it's now square. So let's use 12 by 12. Yeah, it's okay. All right. What else for today? So I think that's all for today. Yeah, that's all for today. So assignments, I say you should learn the following plots: polar plot, histogram, log scale, and so on and so forth. Okay, so this is where I stop now. So see you next time. Bye bye.